All right, recording number 2 for trig functions. We already dealt with sine, now we're going to deal with cosine. The abbreviation is COS, and it's always of an angle measurement. This is equal to the ratio, it's a fraction, of the adjacent side over the length of the hypotenuse. So again, adjacent here is next to. Hypotenuse is always across from the 90 degrees. So let's look at a couple set up. Here we're dealing with cosine. So when you look at your theta and you find your reference angle, you're going to have one value that is adjacent and one value that is your hypotenuse. One value that is adjacent and one value that is your hypotenuse. One value that is adjacent and one value that is your hypotenuse. So when we set it up, we're going to be setting up for each of these the cosine of theta. And here we're using theta because we don't have a particular angle measure. Cosine always equals the adjacent length over the length of the hypotenuse. So when we set up our fraction, we have the cosine of 1 over 6, because it was a cosine of theta, equaled the adjacent over the hypotenuse, and all I did was reduce. Not a big deal. Here I had the cosine of 5 over 11, because the value of the adjacent went on top, and the value of the hypotenuse went on the bottom. And for the third, I have the cosine of 5 over 6. The adjacent value always goes on the top of the fraction, and the value of the hypotenuse always goes on the bottom. 3 problems down below. Similar problems. Here we have angle measurements, so we'll actually be solving for x. So for the first one, 50 is my reference angle, so I'm going to have the cosine of 50 equals. It equals a fraction, the fraction of the adjacent value over the hypotenuse. How do I get x by itself? I undo the division. So 11 times the cosine of 50 ends up equaling x. I'm going to go back to Desmos. Get rid of these. So 11 times, here we're looking for cosine, make sure you hit the right button, of 50. And it equals 7.07. So the purpose here, sine works when we have one angle measurement and 2 lengths. Cosine also works with an angle measurement and 2 side lengths. The only difference between sine and cosine is that in cosine you're looking for an adjacent length as opposed to an opposite length, because I don't know the opposite length here, so sine won't work. For the second one, I have an adjacent length to my angle, and I have the hypotenuse. So because I have adjacent and hypotenuse, I'm using cosine of 57. The adjacent value goes on top, the hypotenuse value goes on bottom. How do we get x by itself? Because it's being divided, just like in the first one, 11 was divided, so we multiplied by 11. X is being divided, so I'm going to multiply by x. I have x times the cosine of 57 equals 2. X isn't by itself yet. The cosine of 57 is just a number. I know it looks like a word and a number and whatever else, but the cosine of 57 is a decimal. It's 0.5 something. So it's essentially the same as wanting to divide by a decimal. I'm going to divide by the cosine of 57 and divide by the cosine of 57. The calculator is capable of handling doing that division. So 2 divided by the cosine of 57, I got to get that down in the bottom, ends up equaling 3.67, rounded to the nearest hundredth. So this length here is 3.67. Last one. Why don't you pause it, see if you can set it up, and then see if you can type it in. All right, so for the third problem, I ended up with an answer of 4.91 because the x value was the adjacent, the 6 was the hypotenuse. So when I set up my cosine of 35, the top of the fraction is always the adjacent value. The bottom of the fraction is always the hypotenuse. Just got x by itself, typed it in my calculator. Tangent, here's the last one. Tangent is abbreviated TAN, and again, it's of a particular angle measurement. We call it theta. It is equal to the ratio. It's one more fraction. This is of the opposite side over the adjacent side. If you think about these three particular ratios, sine, cosine, and tangent, I told you at the beginning we had the idea of opposite, we had the idea of adjacent, and that of hypotenuse. Cosine dealt with two particular ones. Sine dealt with these two. Cosine dealt with these two. Tangent's going to deal with the last combination, which is opposite over adjacent. So if you find your reference angle, opposite is always directly across, adjacent is next to. Let's see how we set them up. It says find tangent theta for each of the following triangles. First thing I would do is label. The 4 is the opposite. The 3 is the adjacent. The 2 is all the way across the figure here. It's the opposite. The 4 is adjacent. For the third one, 5 is the opposite. 7 is the adjacent. This value here is the hypotenuse. It's not helping us. There's nothing there. This value here again is the hypotenuse. It's not helping us. Nothing's there. Same thing here. So it still is the hypotenuse. We're not using it though because there's no value. Because we're dealing with tangent, tangent of theta always equals the opposite length on top and the adjacent length on the bottom. So when I set this up, my first one's going to be the tangent of theta. The opposite value is the 3, so it's going on top of the fraction. The adjacent value is, I said that wrong. The opposite value is the 4, it's going on top of the fraction. The adjacent value is the 3, so it's going on the bottom. You cannot just have tangent equals. It needs to be tangent of theta because this is an angle measurement. So here's the third one, or the middle one. Tangent of theta equals the opposite value over the adjacent, and I reduced. Tangent of theta equals the opposite value, which is the 5, over the adjacent, which is the 7. All right, so these bottom two, find the value of the variable in each triangle. I'm going to label everything first. Opposite, adjacent, opposite, adjacent, opposite, adjacent. And if you notice, the hypotenuse is empty. There's nothing there in all three of these. When I set this up, it's always going to be tangent of theta equals the opposite value on top, the adjacent value on bottom. Tangent, and instead of theta, I'm using 37. The opposite value is x over the adjacent, which is 7. Tangent of the angle value is the opposite value over the adjacent. And lastly, we have the tangent of theta equals, write it down, what do you think? The opposite value over the adjacent. Now we need to figure out how to type these in. Calculator-wise, to get x by itself, I'm going to multiply both values by 7. So 7 times tangent 37 equals x. I'm going to come back to that in a moment. The middle one, I need to get x by itself, but it's in the position of the thing that's getting multiplied, just like my 7s. X times Tangent 62. I need to get it by itself. Undo the division. I'm sorry, undo the multiplication by division. I'm going to type that in here in a second. And then my last one looks just like the center one, so I'm going to have you guys. Okay, so here are the answers for the first one. X equaled 5.27, middle x equaled 1.06, and for the third, I needed to round. X equaled 3.13. I rounded because if we're rounding to the nearest hundredth, this value is higher than 5 or higher, so it rounded it up. So here's the kind of shortcut to remembering. It's referred to as SOHCAHTOA. Think about Indian tribe. That's why there was a picture of an Indian on the front. Sine is the opposite over the hypotenuse. Cosine is the ratio of the adjacent over the hypotenuse. And tangent is the ratio of the opposite over. So tangent is the ratio of the opposite over the adjacent. SOHCAHTOA. Might be helpful to write it on the top of your paper so that we can figure out which one is which. All right, so here are a handful of practice. What you have to do is first decide which ones it's going to be. Is it going to be sine because you have opposite over hypotenuse? Are you going to use cosine because you have adjacent over hypotenuse? Or are you going to use tangent because you have opposite over adjacent? So the first thing that needs to happen is that you go through and label. If 15 is your reference angle, this is an opposite, this is hypotenuse. 80, 11 is opposite, adjacent. For number 3, let's see, this is opposite, adjacent. And for 41, or I'm sorry, for number 4, from angle 41, opposite and adjacent. Go ahead and pause the video and set up your ratios. All right, so here are the fractions I set up. Because for the first one, I had an opposite, and because I had a hypotenuse, that tells me to use sine. Opposite over hypotenuse, you're going to need to solve for x. I'll show you that in a moment. For number 2, I had opposite and adjacent. So opposite and adjacent told me to use tangent. For the third one, I had the opposite and adjacent, so also telling me to use tangent. And for the fourth one, when I labeled originally, I labeled opposite is over here. And even though that is the opposite, there's nothing over there, so it's not helpful. So what I need is the one that has the adjacent and the one that has the hypotenuse. So cosine of 41 equals adjacent over hypotenuse. Go ahead and pause the video and work with getting x by itself and typing those into your calculator. All right, go ahead and take a second to check your answers. I think the hardest part of this is figuring out whether to use sine, cosine, or tangent. But once you have determined whether to use sine, cosine, or tangent, you set up the fraction and solve, and that's very repetitive. All right, for sake of time, I'm going to ask that you attempt these 3 problems on your own, 2 problems on your own, and I will make sure that you have the answers available to you in class. And then the last slide is just a summary. We always want to make sure to locate the reference angle, label the sides, write your formula, plug in the numbers, and then here's a little trick to whether you're multiplying or dividing. There's your sine, cosine, tangent, and a couple of examples. Good luck. Please email me with questions.